Okay, we have here a bunch of drunk Android phones. No, in fact what we have here is a completely asymmetric, decentralized mesh of telephones all running Serval mesh Android app. Unfortunately they're all Androids, you can tell by the fact they've all got 3 buttons at the bottom, not one. And to date, what Paul's talked about is using these in order to place voice calls, so that's been the primary motivation. So that the idea is that with this mesh you could have this anywhere as long as they all had enough battery power and that all of them actually had ad hoc Wi-Fi working, which is actually quite a challenge. The only way of doing that on contemporary Android devices is to first of all root the device, so get a super user, replace the boot firmware, install a super user app, then grant super user application via that app to the Serval mesh application when it starts, and then it can turn on ad hoc mode. And then, provided that all of these phones, A through K, have managed to do that, then you can have a mesh like this. And you can see A can easily call B, and D, you can make phone calls directly to each other. And possibly with a bit of luck and routing, you can actually make phone calls so that H could even call all the way to K there via all the intermediate ones. So that's voice calls. However, what I'm going to talk about is an application called Serval Maps, which has been developed at the Flinders University where the Serval project is based. And Serval Maps is a little bit similar to Google Maps. You start it up, you download it, it's very, very much prototype version software. But it's the basic idea is that you get a map of your surrounds, which you can zoom in, zoom out. You can see where you are if you've got your GPS turned on your phone or on your device. And at that point, the comparison starts to fall down because Google Maps is very much a consume-only proposition, as you can use it to get lots of information. If you want to put information there, sure, you can publish web pages, search, and so forth, but in Serval Maps what you can do is you can actually take a photograph or fill in a report or create a file tagged with the geolocation of where you are and then share it via the Maps application as what's called a point of interest. At that point, Serval Maps will use the Serval Mesh application to send that to all of the other devices participating in the Serval Mesh using a file distribution component of a Serval Mesh which we call rhizome. Does anyone know what rhizome means?
Roots of a plant?
Yes, the roots of a plant. If you come across couch grass, the thing about couch grass, if anyone has a house with a lawn, is that if it gets in, you cannot eradicate the thing. As soon as it gets its seed in, it starts to grow, and it sends tubers along underneath the ground and keeps sprouting up. So even if you think you've pulled it up, if one little bit remains, then pretty soon you'll get a bit coming up, and then it'll start coming up everywhere. It's sort of, yeah, it lives under the ground and keeps popping up. The only way you can eradicate it is to eradicate every single scrap of couch grass material in your lawn.
And it's even about a foot down, stripping up all the topsoil and then replacing it.
Yeah, some people say the only thing you can do is basically do that and then plant potatoes for 3 years, and dig them in and so forth until that's what it takes to eliminate a rhizome-based lawn. So we thought that was a pretty sort of suitable name for this because that's more or less how this works. Another question: how many people have ever actually used or remember or even know what Usenet is? Oh, hey, fantastic. Okay, well think of Rhizome as Usenet for the mesh network. Right, now Usenet worked when you published an article in Usenet, a bit like sending an email. You're sending it to everyone who read that news group. And the way it propagated was that it copied that article to every single machine that was hosting Usenet. And when 2 machines got in contact with each other, they would send each other a whole list of, well, I have these articles. And the other one would say, well, I have these ones. And they'd think about it for a while and say, well, give me that one. And the other would say, well, give me this list. And then they'd busily exchange articles, then hang up. Result, you'd have an identical copy of everything on both machines. And it was just basically repeat this several times a day, wash, rinse, repeat. So eventually, the article that I write somewhere in Sydney ends up copied to all of the machines in California, in the United States, in Europe, and everywhere. Eventually, it gets there because it just propagates from machine to machine, whatever path it can find. It was that aspect was what prompted Gene Spafford to make the comment that the internet treats censorship-like damage and simply routes around it. People's attempts to shut off Usenet feeds by simply closing down or block specific news groups or drop block specific posters came to naught because the article wouldn't get in through my feed, but it would get in, it'd go to Russia, it'd go to Belarus, it'd go through Europe, it'd go to the UK, it'd go from the UK to New Zealand, from New Zealand to, and it'd end up on the University of, on Berkeley's computers, however. And that's basically what Rhizome does. So this is an interesting, well, it's an overcomplicated architectural diagram of pretty much what we've built, and I'll be going into this in far more detail later on this afternoon. I think it'll be the last talk in this session today. You'll see in here we've got sort of 3 blobs. That's Linux, which is the reason we're all here. At the top is an Android application called Batphone, which is actually the Serval Mesh application, and that's all written in Java. And in the middle, we've got this piece, which is all written in C, which is it's a daemon process. A daemon process is basically like a program that's just running all the time and responsible for providing service to everything else. A daemon process, a good example of that is the process that does your printing. It's sitting there waiting all the time to be told here's a print job, and then it knows to send it off to the printer. So on most Unix systems, on Android systems, there are dozens of daemon processes just sitting there waiting to do their job all the time. So we've written our own, and we call it Serval D, which means Serval daemon. Very original. And in there, one of the pieces you'll see is this bit, Rhizome. Rhizome is let me see, I've got some notes here that go into it a bit further. Now, Rhizome was inspired, or the idea for Rhizome sort of grew up along with the ideas for Serval Mesh. And if you think about the mapping sort of devices that you can get and carry around with you, you've got Google Maps and Apple Maps and so forth like that, which are, you need to have internet connectivity to be able to search them. You wander into an area where you don't have a detailed map cached on your phone, you can't get a detailed map unless you can download it. So it assumes, like most of the mobile thinking and most of the commercial mobile offerings today, it assumes that you're within range. You've got coverage and you've got internet there. In the situations that we were thinking about, which is in post-disaster response areas, in remote locations, bushwalking or report gathering or data gathering out in the field, there is no coverage. So that has to go out the window. Other sort of devices, you can get things like your GPS, your TomToms and so forth, which people put in cars. They cache the entire map right down to all the detail on the thing. You have to pay for the upgrades, in fact. So they've got a huge cache of all the maps you need. So that's fine, but it's a one-way device. All it's doing is telling you how to get from A to B. If you come across a dead badger in the middle of the road and you want to report it, well, tough. There's nothing for doing that. We wanted Serval Maps to be able to do that. So the idea with Serval Maps is you're walking along. In fact, this is one of the, shall I mention the Caltrop one? Yes, please. Okay, the local council in the area where we work in Adelaide have a problem with Caltrop. Who knows what Caltrop is? Three-corner jacks. It's a nasty weed that grows. It flowers. It stays very close to the ground, and it produces these very nasty little 3-pronged prickles. Yeah, you don't want to know about them if you ride a bicycle or if you like to walk about in barefoot or with soles less than about 2 or 3 millimetres thick, because they're really painful. Anyway, it spreads all over the place. It spreads along the sides of bike tracks, along the sides of roads, it spreads through people's gardens, it goes everywhere. And local councils spend all their time trying to eradicate this thing, particularly if they're in an area where there's lots of bushland. So they have a bunch of gardeners and a bunch of council workers that go around and they somehow respond to reports that they've got a lot of Caltrop here. They have to go around and as they're driving around and doing their work, they have to eyeball and look for the thing. So they came to us and we said, well, you could use Serval Maps. We could cook up a solution for using Serval Maps. The idea is that your guys are out in the truck, they've got their Android phone with them, running Serval Maps. As soon as they see a Caltrop's infestation, they don't just drop what they're doing or fill in a piece of paper. They can just take a photo of it, hit share on the photo, up pops a menu, share via Serval Maps. Hit that one, bingo, it's in. Now, they may not have a mobile data plan on their mobile, so it doesn't get shared straight away, but as soon as they go back to their base, their Android phone meshes with the other Android phones, or in fact the other Android server, the Serval server in there, and immediately uploads all of the photos that they've shared into there, which means that at base, they now have all the photos that all of the field workers have brought in with them. And in fact, all of the photos that all the other field workers have taken have now gotten onto everyone else's phone as well. So that when they come across, when someone else comes across the same patch of caltrop, they pull it up and they see that there's already about 4 photos of it. They look at, because when you look at the Serval maps, you can actually see all the points of interest that people have shared at that point. And so, well, there's no point, I'm not going to take another photo of that. Even better, anyone else in the region who happens to want to carry around Serval maps installed on their Android phone can come across a bit of caltrop, take a photo, share it, and as long as they come into contact with a council worker or happen to go to the council offices, or if the council make it available, simply collect it via the internet so they go back home within range of their personal home router, that photo will find its way to the council. So it's a way of the general public doing data gathering for the local council. This kind of thing is extremely useful for disaster response teams, where you really need to be able to document, there's no bridge here, you know, there's a water mains burst here, that hospital is in ruins, you know, there's some really nasty, badly hurt people here, and so forth and so on. Just take photos of them, fill in a report, write a text or something like that, and put it in. And eventually, those files will find their way via Rhizome to the place where they're needed, which is usually the central command place. It could be that everyone in your team ends up with copies on each other's phones. One of you gets in a helicopter, gets airlifted, goes to central base. They're carrying all of the Rhizome files on their phone. At central base, suddenly it spreads out and it's everywhere. So Rhizome is very opportunistic. It will take advantage of whatever vector or whatever manner it can use to get a file from point to point, as long as someone is carrying it or has copies on the phone. So how did we build Rhizome? Well, some of the requirements that we looked at for Rhizome was that it has to work, of course, without continuous connection. You have to be able to send files and receive files. You have to be able to publish and pull content. It uses flood distribution. Privacy and security became basically the next top requirement. And we had to figure out how to make it possible to share a file with a limited group of people, or share a file for one specific recipient that can take advantage of the flood mechanism to get a file to one person. Or you also have to be able to share a file anonymously, so that you can put it in there but no one can tell who actually created it. The idea is that once you've got copies everywhere, you can't tell where it originated, which device was the original device that took that photo or published that video or published that naughty blog post or whatever. And it needs to be resilient. Well, the flood routing mechanism is basically how we achieve resilience. And it also has to be able to offer an API to other applications so that things like Serval Maps can use Rhizome as their data transport mechanism, so that eventually we'll be able to publish an API for Rhizome, so that programmers can take it and say, well, I just want to write a program that just collects interesting data or creates interesting files or shares files, and it does it using Rhizome. And it then can inquire to Rhizome to see what other files of my type of my application have come my way. So this is what we're working towards. Some of it's done. There's a lot yet to be done. However, all of the Serval mesh versions that have been installed that we've got around all have a version of Rhizome running, which has been mostly tested. It's pretty good. Still got a few bugs. But if you use the center button of the Serval screen, which says Share Files, there's a button you can see says Find Files. That will list all of the files that currently Rhizome has on your phone. And there's a couple there which we've shared already, which is the Serval software itself. There's the APK file. And there's also an APK file for Serval Maps. If you simply save that and open it, your phone will start to install Serval Maps. So we actually distribute the three applications that we use Rhizome for at the moment are Serval Maps, Mesh MS, which is basically we use Rhizome to implement Serval's form of SMS. So when you send an SMS message to someone, it actually creates a Rhizome file, injects it into Rhizome and just says, you're on your own, get there somehow. And it does. And as soon as it gets to that person's phone, up will pop an alert saying, you've just received a message. This is very interesting because this means that your message will get to that person however it possibly can. It doesn't matter if it has to be carried by some guy on a camel for 3 hours. Going to the next village, it will get there.
So what is the rate for IP over camel?
IP over camel, well, you know the old expression, never underestimate the bandwidth of a station wagon full of mag tape. I guess I never underestimate the bandwidth of a camel with a guy carrying an SD card. Yes.
About that, is there a mechanism through which MS knows that it's been delivered, so other
there is. There is. We've been probably too clever for our own good here. We think big. I'll just mention the one other application which I said, which is we use it for distributing software upgrades of our own software. So I'll address that. The way that MeshMS uses Rhizome is it creates a Rhizome file, and every new message appends onto the end of it. So you've got this file that keeps getting bigger and bigger and bigger. Eventually, Rhizome says, I don't care about the front part of the file, and stops carrying it, and only carries the last portion of the file, so you don't get this thing that's growing without limit forever. That bit isn't implemented yet. At the moment, MeshMS causes files to just grow and grow and grow. Fortunately, messages are not huge because MeshMS only carries text like standard MeshMS at the moment.
We've got a question up the back.
Question up the back.
In the version of Serval that you distributed this morning, MeshMS seems to crash.
Yeah. When you go into the messages screen, it crashes?
I think that's an issue with, it's different on Ice Cream Sandwich. There's a permission that's required for something we're doing. We haven't.
Right. So it doesn't have permission.
It may be specific to signage more.
Right.
I'm not sure.
That would be why.
Yes.
Do you collect a log?
We've already got the log report for that one.
It won't let me log anything when it crashes.
So
Right. Okay, well, if that's being tracked as an issue already, then
we may already have that one.
We'll fix that.
So you just want to mention the prioritisation rule inside Rhizome?
Ah, yes. So I'll just finish that question about MeshMS. So when you have a conversation, a MeshMS conversation with another person, you actually have two Rhizome files. One is the messages I'm sending to you, and the other one is the messages you're sending to me. And both of them form a conversation. And both phones at each end will have a copy of them. So I can tell, or the MeshMS software can tell where you got up, because when my message arrives at your phone, it records an acknowledgement in your file, appends it, which finds its way back to my phone. And so by simply inspecting your incoming messages, I can see which messages of mine you've received already. So it turns out to be quite clever. There's an acknowledge system built in, which actually makes it more useful than SMS over standard telco or standard mobile plans, because when you send an SMS to a friend of yours, good chance it's been delivered, but you never actually know. You send the SMS out there, out it goes into the wild blue yonder. You kind of hope that it's gotten there. You'll find out when they ring you back and say, "What did you mean, blue?"
Well, why did you send this 3 days ago?
Yeah, so why did you send me this? Yeah, why didn't you send me this 3 days ago? Well, I did send it to you 3 days ago. In Rhizome, you actually get an acknowledgement eventually that it's arrived.
We're at lunchtime now, so if we want to do we want to do any more questions, or do we want to go and eat, or it's up to you guys. If you want to bother the Serval guys while they're eating. I think
we're eminently botherable.
One question at the back.
Very briefly, you mentioned delivering updates with Rhizome.
Yes.
That has the potential to be very fast, especially if you're just using certificates for authentication. How do you know a piece of code is trustworthy, and how do you know it's not? And if it's distributing all across the entire network, this is a beautiful way to do a lot of evil.
Oh yes, the potential for evil is very high.
Firstly, Android won't let you install an APK unless it's signed by the same person who's signed the version you've already got. So you can't upgrade unless the author knows the same private key. And we've got another layer. Every Rhizome bundle has a similar public-private key pair that requires the same person to sign it to publish the new version. So, provided you trusted the person who you got the software from in the first place, the software update is from the same person.
So each device has the same private key pair?
Each Android application has a signing key, and every Rhizome bundle has a signing key.
But in future, we're going to move towards a quorum model for signing.
So but obviously, if the US government twisted our arm enough through the court system and asked us to patch the software and release a signed version,
that's not your biggest problem.
No.
There's other problems. The software is obviously GPL, and we invite people to inspect it and build their own versions if they wish. And we may at some point come up with another way of trying to verify that this build came from this tarball.
But so more generally, the interesting thing, like the whole LimeWire network shutdown thing, where the organisation was seized by Coldwater, I think, and they got the crypto keys. I can't remember the precise details, but essentially they put an update out that was designed to then shut the network down after it had time to propagate widely through itself. So the quorum approach, we've got a grant in that hopefully we'll get up with informsec.net to implement a quorum system. So we might approach, for instance, the Free Software Foundation and a number of other organisations, and then each further update of the Serval mesh will actually need to be signed off by some minimum number of that pool of hopefully reasonably trustworthy organisations.
Yeah. And they won't all be American.
No, they won't all be in. And we'll hopefully have some in.
Australian, a European, and American. No,
and places that don't have mutual extradition treaties with one another.
It's a really small cross-section you've got there then.
Yes, so Ecuador might. So
all right, I think we're done for now.